1, 2, 3, come on!
Hello everyone. Today I have taken the question from class 12th. The chapter name is capacitance. In this chapter we are going to learn how to find out the equivalent capacitance between two points. Most of the students will find the difficulties while they are finding the equivalent capacitance between the points, especially if the connections are in infinity, for the infinity ladder. Now I'm going to teach you that how easily that you can find the equivalent capacitance. Here it is the connection. So now you can see that the capacitance which is connected in series as well as the parallel. You must know the combinations of series as well as parallel. Now observe in these two. So you can observe the capacitance. So these two capacitance are connected in series and these two are connected in parallel. Similarly, these two are in series and these two are in parallel. You remember this. Okay, so then what will be the next one? Actually, so I have showed here as a till infinity. It means there will be a one more connection. So with the capacitance of 4 microfarad, right? Now, so next another one, definitely there will be a one more series and there will be another one parallel capacitance which is connected to this one. Is that only one? No, there will be another one till infinity. It means we don't know exact how many terms. It doesn't end here itself, so that's why we have taken it as infinity. Okay, so then how to find out the equivalent capacitance here? Okay, so first initially what you have to do means, so in this circuit diagram, so you can observe that so there are so many circuits that you can see. So till here, means you must know that if it is ends means you know that till the, I mean from the last point or further point you have to take the values. So when it is ends, now it is infinity, no? So that's why. So we are leaving this first terminals and then till from here to till infinity there will be a capacitance, right? So equivalent capacitance, but we don't know that equivalent capacitance. So what we'll do, we'll take it as some other variables. We are learning a capacitance. Let us take it as C itself. Okay, let me draw that. One capacitance as well as which is connected to one more series, right? Now this total equivalent capacitance, okay, so think it is C. Okay, so equivalent capacitance will comes in parallel. Okay, so let me take it as C. What about this one? How much? 4 microfarad, and this one is also 4 microfarad. Clear? And here it is A and B terminals. Okay, so now I have taken this one as a C, equivalent capacitance of full till here. Now let me tell you one thing over here that you're supposed to understand. So imagine this is the equivalent capacitance till here, the equivalent capacitance as a C. Okay, so if I add up with this, do you find any difference? For example, it is connected in series right now. So if it is connected in series means if you find that how much means, so series 1 by 4 plus 1 by 4, so then definitely you will get 1 microfarad. If you add so equivalent capacitance of this one to a 1 microfarad, do you find any difference over there? I think you are finding the difficulties. I'll tell you one example here. Just imagine that you have a 10,000 rupees in your pocket. Okay, so let me add up 1 rupee coin with that 10,000 rupees. Imagine that. Okay, so now you do whatever with that money. You can go out, you can do a party. Okay, so just imagine that your friends came with you. Okay, and now they are asking that do you have a money? Yeah, of course I have. How much you have? Okay, so you don't worry, you will say that you don't worry, I have a 10,000 rupees, you take whatever, I'll pay the bill. Are you going to say that 10,000 rupees, or are you going to say that 10,001 rupee? Okay, we used to say that definitely as a 10,000 rupees. Imagine that the total capacitance of this one, it is 10,000. I just added with the 1 rupee here. Okay, so do you find any difference in this? So usually you say that as a 10,000 rupees, I have a 10,000 rupees. You are not going to mention that it's a small amount right now. So likewise, okay, so you can't find out any much difference between these two capacitance, right? So equivalent capacitance or total capacitance, isn't it? Remember that. Okay, so remember that. Now let's go here, the next one. So the circuit is like this. Now what is the connection of this? It is connected in series right now, isn't it? Okay, so then let me take that 4 microfarad and C are connected in series. If it is connected in series means how you going to solve this one? So let me take that one as equivalent. So equivalent resistance, capacitance of this one, it is 1 by C dash. Let me take it as C dash, that is 1 by first one, let me take it as 1 by 4 plus another one 1 by C. Okay, so this is how we are going to find out the equivalent capacitance when it is connected in series. You must remember that. Okay, so resistance and capacitance don't combine. So here capacitance is totally vice versa of the resistance. Okay, remember that. So to find out the equivalent resistance capacitance means here it is. This is how we are going to find out. Okay, so now we can simplify. You can write it directly also, only if you know. Okay, so LCM 4 into C, so then C plus 4, that is 1 by C dash. Okay, so now let us reciprocal this one, so then C dash will become 4C divided by C plus 4. Okay, so here it is, the value of C dash. C dash means the equivalent resistance till here, the equivalent resistance till here. Okay, so now the equivalent, what will be the circuit? Means the circuit will become capacitance, and now equivalent capacitance we already got here right now. So then it is connected in parallel, and this is 4 microfarad, and this one how much? C dash. Correct? Equivalent. So here we got. And now observe carefully. Okay, so these two are connected in parallel. So here I can write it as 4 microfarad and C dash are connected in parallel. Okay, so if it is parallel means what will be the equivalent resistance, capacitance of this one? So that is, let me take it as what I can take. So shall I take it as C equivalent or C dash or something? Okay, so let me take it as C equivalent. So C equivalent is equals to, so 4 microfarad, let it be, I don't need to write, and C dash. Okay, so here it is, series connections. This is how to find out the equivalent resistance when the equivalent capacitance, so in between I'm going to say resistance, so that's why. Okay, so equivalent capacitance when it is connected in parallel. Okay, so now observe, as I told you before, here it is, equivalent resistance is that C dash. Okay, so C dash value we already have here. Okay, so this equivalent resistance, as I told you in this, are we finding any much difference here? No, if I'm going to add with this, No, we don't. Okay, so that's why can I take this means the equivalent of capacitance is C right now. So then the total is, I have taken it as a equivalent capacitance. So then equivalent capacitance, then I can take it as C now. So because we are not finding much difference, that is a very important point that you're supposed to remember here. Okay, so then this one I can take it as C because of that example I gave now. So 10,000 rupees and 1 rupee. Okay, so this is just a 1 rupees and the total one it is 10,000. So that's why. So then I can write it C. Okay, so this equivalent resistance I can take it as C. Then 4 plus C dash means how much the value of C dash is here. So that is 4C divided by C plus 4. Now you can take LCM. Okay, so C you just write as it is. You can take LCM, that is C plus 4 is the LCM. So then 4 into C plus 4 plus this 2 will get cancelled, remaining 4C. Do cross multiplication. This one will come over here. C into C plus 4 and multiply 4 into C, it is 4C plus 4 4s are 16 plus 4C as it is. Again you multiply C into C, that is C square plus C into 4, it is 4C equals to, so 4C plus 16 plus 4C. Now if I send this one into left hand side, it will become negative right now, then these two will get cancelled, remaining terms you just send it to the left side. So C square, so then minus 4C minus 16 equals to 0. Now if you observe this one, it is in the form of ax square plus bx plus c equals to 0, right? A quadratic equation form, standard form, right? Okay, so here what is the value of a is 1, and what is the value of b is minus 4, and what is the value of c, that is minus 16. And you know the formula to find out the roots right now. So that is minus b plus or minus square root of b square minus 4ac whole divided by 2a. Okay, so what is the value of b over here? First minus b as it is, you write minus b means it is nothing but minus 4. So plus or minus square root of b square means minus 4 whole square minus 4 into a means 1, c means it is minus 16 whole divided by 2 into a means it is nothing but 1. Okay, so let me solve this one for you here itself. Okay, next minus 4 into minus into minus plus, that is 4 plus or minus square root of minus 4 whole square. Minus 4 whole square means it is nothing but 16. Now you can observe minus into minus, that is plus. You have to observe with the sign. 4 into 1 4 and 4 into 16. 4 into 16 how much? Here only you can do it. 4 16s are 64 whole divided by 2 into 1, that is 2 itself. Okay, yes. Next 4 as it is, you write plus or minus square root of this one 80 whole divided by 2, and thus 4 plus or minus 80 you can write it as 4 into 20, right, whole divided by 2. You can simplify, still you can simplify, and 4 plus or minus 4, if I took it out means I can write it as 2 root 20 whole divided by 2. I can take 2 as common over here, so 2 if I took means 2 plus or minus square root of 20, so then divided by 2, 2 will get cancelled, so the answer is 2 plus or minus root 20. So there will be a no negative over here. Okay, so then the answer it is 2 plus root 20 is the answer. Equivalent resistance of thus given circuits. Understood? Yeah, okay. Thank you.